Welcome to the Department of Chemistry at Emory University. My name is Frank MacDonald. I'm Professor of Chemistry and the Safety Liaison for our department.
This video provides information on safety and the evacuation plan specific to the Chemistry Department at Emory University. Please complete the online research safety course for the university before you continue with this video. You can access the Emory Learning Management System through the Emory Human Resources website. With safety, Emory University has a responsibility to provide a safe working environment, but we each are responsible for carrying out our individual tasks in a safe fashion. To this end, we should help each other with compliance with the safety codes, particularly adherence to the use of personal protective equipment. I also wish to remind everyone that laboratory safety is an essential part of our training. Please take a look at the Chemistry Department Safety website. This page has emergency numbers and contacts, and links to useful videos, our monthly safety newsletter, the names of safety officers for the various laboratories, a link to the safety data sheets online, and links to various forms and paperwork for waste disposal. One of the most important issues is the use of personal protective equipment. This includes eye protection, different types of eye protection, whether you're protecting your eyes from chemical reagents or solvents, or from high-intensity laser light. You should also wear gloves that are appropriate for the task. Protective clothing includes a laboratory coat and clothing that protects the legs and the feet, including closed-toe shoes. It's important that you do not work alone in the laboratory. Make sure that other people are around and that they know what you're doing. Although inexperience has been a contributing factor to laboratory accidents, overconfidence can also be the source of considerable hazard. Please take a look at least one, ideally both, of these videos, which describe the consequences of acid burns suffered by laboratory researchers who were not wearing the appropriate personal protective equipment and were also overconfident or in a hurry with a procedure that was just going to take a moment. Please limit the amount of flammable solvent that is stored in the laboratory. The solvent should be stored in flammable liquid storage cabinets, and please rely on the chemistry stockroom for long-term storage of large quantities of solvent. The chemical fume hoods are there to protect workers not only from exposure to chemicals, solvents, and reagents, but can also protect against fire and explosions. For the hoods to work properly, particularly for them to protect against fire or explosion, the hood sash needs to be down as low as possible. The ventilation systems in our buildings work best when the laboratory doors are closed. With regard to the equation PV equals nRT, it is the correlation between volume and the number of gas molecules that's relevant here. The next section deals with what to do in case of an emergency. In the event of an emergency, it's important that you have already thought through what you will do so that you don't have to consult a guide or think too much about what needs to be done. You should be able to react in an emergency. If the fire alarm sounds, your top priority is to evacuate. Do make sure that everyone in your immediate area has heard the alarm and is in the process of evacuating. If you're in the middle of an experiment, secure that experiment as best as you can to prevent there from being a bigger problem, but that should take only a few seconds. If you are in the same room as your keys, your purse, or laptop, you may want to take that with you, but if you cannot grab those within a few seconds, you must evacuate without them. As you leave the room, close the door to prevent the spread of any fire, but do not lock the door in case first responders need to enter to see if anyone needs assistance within. And of course, you should use the stairs, leave the building by the nearest exit, and gather at the P-Vine parking deck on the ground level. This map shows the location of Atwood and Emerson halls, and the location of the P-Vine parking deck is marked with a star. Once you reach the P-Vine parking deck, check in with a representative of your laboratory, ideally your advisor or the laboratory safety officer. Once they have confirmed that everyone is accounted for that was known to be present in the laboratory at the time of the alarm, they will check in with me as a safety liaison. Do not re-enter the building until an all clear has been given by a member of the safety team or one of the firefighters. If you should need to use a fire extinguisher, there are several steps that you should think of ahead of time. The first thing to do is to alert others that there is a fire hazard. Pull the fire alarm if there is one that's nearby. As you take the extinguisher and return to the fire, be sure that you keep your back to an exit so that if you cannot put out the fire, you have a way out. To use the extinguisher, remember the acronym PASS, P-A-S-S, for pull the pin, aim at the base of the fire, squeeze the trigger which will release a dry baking powder mixture, and sweep to make sure that the fire is out. Do not turn your back on the fire scene until you are completely certain that the fire is out. If you feel that you're putting yourself at risk by attempting to extinguish the fire, you must evacuate. In case of a chemical spill or a release, the Environmental Health and Safety Office has a 24-hour spill team at the phone number listed here. Please enter that number into your cell phone. If you do call the spill team, it's important to let them know anything that you know about the nature of the material that's spilled, the location of the spill, and approximately how much is spilled, whether it's a few milliliters or whether it is several gallons or more. If you or someone in your lab has an exposure to chemicals, use the eye wash or the shower as appropriate. Keep in mind that the eye wash or the shower should be used for 15 minutes. If the person does not use the shower for that long, when they get to the emergency room, the emergency personnel will put them under the shower for that remaining amount of time. In case of an injury, you should seek medical attention from the nearest facility. Generally, this will be the Emory University Emergency Room. An uninjured person should accompany the injured person to the hospital to make sure that they get there safely and to assist in answering any questions that medical personnel may have about the exposure. Once the immediate hazard has passed, it is essential that this incident is reported. There are 3 essential steps to reporting an incident. Number 1, your advisor or supervisor should be notified. In addition, the chemistry department safety team should be notified. That will generally be me or Miss Jan McSherry. And it is also essential that the incident is reported to Emory University. This is done through the Human Resources page. Click on the Accident Injury Entry form. You will log into the system and then give the information on the incident or accident. For a fire that requires any mitigating measures, even if it is simply smothering the fire with sand, the Emory Police must be informed. If a fire extinguisher is used, you also need to request immediate replacement of the fire extinguisher. Near misses should also be reported. In these cases, usually it's only one thing that went wrong, instead of the several things that are often associated with an accident. But the benefit of reporting near misses is that we can learn from these incidents and improve the preventative measures that are in place in the laboratories and in our protocols. The law requires that any injury occurring in this building or in the laboratory must be reported, even a minor injury. I will conclude this department-specific safety briefing by asking you to follow up with your faculty advisor and the laboratory safety officer. Please discuss what safety equipment is in your area and where it is located. It's also very important to discuss hazards that are specific to your laboratory and hazards that may be in your specific experimental work. Then please locate the nearest fire extinguisher to your work area and then the second closest fire extinguisher as a backup. Likewise, notice the nearest and the next nearest fire alarm pulls, and then find 2 exit pathways from the building. Please remember that safety training is not done with this orientation. Safety training is an ongoing and daily activity. It's important to regularly review and refresh your memory of safety protocols. And as new experiments or new equipment comes into the laboratory, there will be new safety protocols that need to be developed as the research progresses. If you have any questions, please feel free to contact me, Professor Frank McDonald, and my email address is given at the end of this video. Thank you.